Welcome students. In this first module of reflection of light, we will be learning what is light and reflection of light, which already you have learned in standard 8. Then we'll see mirror and various types of mirrors. After that, we will learn in detail the image formation by mirror and various phenomena and the effects produced by a plane mirror while image formation. For example, lateral inversion, etc. So first, let us know what is light. Light is an agent which gives us information about what is happening in our surrounding. We can enjoy various wonders of nature like the sunrise, sunset, and rainbow only because there is light. It is only because of light that we can see the vegetation, colorful flowers, stars shining in the dark night sky in this beautiful world around us. So, how actually it happens? This you have already learned in your previous standard that when the light rays falls on any object, they get reflect from that object and the reflected rays enter in our eyes and we get the sensation of vision. And this is nothing but the reflection of light. And the light is nothing but the electromagnetic radiation which causes the sensation of vision. As I told you before, when light rays fall on an object, their direction changes and they turn back. This is nothing but the reflection of light. Now, look at this picture. You can see here the rays falling on any surface are called as incident ray, and the rays going away from the surface after reflection are called as reflected ray. The angle made by the incident ray with the normal is called as angle of incidence I, and the angle made by the reflected ray with the normal is called as angle of reflection angle R. Now, depending on the surface, there are two types of reflection. Here you can see the surface is smooth. So here all incident rays are parallel to each other and also the reflected rays also parallel to each other. In this case, all angles of incident I are equal to all angles of reflection angle R. So, the reflection of light from a plane and smooth surface is called regular reflection of light. Now, here you can see the surface is rough. In such case, all incident rays are parallel to each other, but the reflected rays are not parallel to one another and spread over a large surface, as you can see here in the picture. So such reflection from Rough surfaces reflects the light irregularly. Therefore, such reflections are called as irregular reflection. Let us learn what is a mirror. As you can see here in the picture, an object is kept in front of a mirror and we can see clear image of this object in the mirror. So, let us define a mirror. A mirror can be defined as a surface which reflects light and creates clear images. Do you know who invented first mirror? The German scientist Justus von Liebig coated the plain surface of a simple piece of ordinary glass with silver metal and made the first mirror. We use various types of mirrors in our daily life. Mirrors are of two types: plain mirrors and spherical mirrors. Plain mirrors are used in various activities in our day-to-day life. A mirror is made by coating the back surface of a flat, smooth glass piece with a thin reflecting film of aluminium or silver. To protect this reflecting film and to make that side opaque, another coat of a substance like lead oxide is given over it. Spherical mirrors are also very useful to us in our day-to-day life. We see a clear image of ourselves when we stand in front of a mirror in our house. To understand better how an image is formed in a mirror, we need to know some basic principles of reflection. As you can see here in the picture, a plain mirror is kept and the light rays are falling perpendicularly on the mirror, and the refracted ray are also reflecting in the perpendicular direction from the mirror. In such case, the angle of incidence and the angle of reflection both are zero. To understand how an image is formed in a mirror, let us first consider an image formed by a point source. As you can see here in the picture, a point source O is there in front of a plane mirror M1, M2. Incident rays OR1 and OR2 get reflected according to the laws of reflection along the paths R1, S1 and R2, S2 respectively. When these reflected rays are extended behind the mirror, they meet at point O1. When seen from E, the rays appear to be coming from point O1. Thus, point O1 is the image of point O. The perpendicular distance of the image from the mirror is always equal to the perpendicular distance from the mirror of the object. Now, let us see how the image of an extended source is formed by a plane mirror. If we use an extended source instead of a point source, an image is formed of every point of the source and thereby forming an extended image of the whole source. As shown in the figure, a pencil PQ is kept as an extended source in front of the mirror M1, M2. The image of point P and Q are formed at P1 and Q1 respectively. Similarly, images of all the points between P and Q are formed between P1 and Q1, resulting in the image P1 Q1 of the entire extended source. The image formed by a plane mirror is always of the same size as that of the source. Let us learn one important effect produced by a plane mirror. As I told you, the image formed by a plane mirror is of the same size as that of the object. Now, let us do one activity. Stand in front of a mirror and raise your right hand. Now, observe your image in the mirror. What do you see there? You will see that though you are raising your right hand, your image in the mirror is raising its left hand. Now this is called as lateral inversion. Lateral inversion is nothing but the effect produced by a plane mirror in reversing images from left to right. One more example. You can see here the image of a capital letter D appears laterally inverted in the mirror. This is because the image of every point on this letter is formed behind the mirror at the same distance from the mirror as the point itself, and we see the entire image of this letter as laterally inverted image. So, lateral inversion is nothing but the reversal of left and right that we observe in a plane mirror. Let us learn more about plane mirror. Let us do one activity. Place two plane mirrors at an angle of 90° to each other. Place a small object between them. Images will be formed in both the mirrors. How many images do you see? You can see 3 images here. Now, change the angle between the mirrors and count the number of images. Here in this picture, there is an angle of 120 between the two plane mirrors and you will see 2 images. One more example. Here you can see the angle between two plane mirror is 45 and you can see 7 images. Now, how is this number of images is related to the measure of the angle? Here is the formula. N is equal to 360 upon A minus 1, where N is the number of images and A is the angle between two plane mirrors. Using this formula, we can find out the number of images when the two plane mirrors are placed at a certain angle. Here in the table, number of images are given when the two plane mirrors are placed at various angles. Now, carefully observe this table. You will find that when we decrease the angle between the two plane mirrors, the number of images goes on increasing. We have seen that if two plane mirrors are placed at certain angle, we can be able to see various number of images. Now, what if we kept two plane mirrors parallel to each other? How many images will we see? Look at this picture. You must have experienced this in barber shop, where two plane mirrors are kept parallel to each other. There we can see infinite number of images. Now, what is the reason behind this? Let us see. Now, let us see how infinite number of images are formed when two plane mirrors are kept parallel to each other. Look at this picture. Here in the picture, mirror 1 and mirror 2 are kept parallel to each other. An object is kept in front of two mirrors. So, you may see images of this object in both the mirrors. Here is the image of this object in mirror 1 and here is the image of this object in mirror 2. Now, the image in the first mirror may act as an object for the second mirror. So, the second mirror may form an image of this image. Similarly, the image of the second mirror may act as an object for first mirror. So, first mirror may form an image of this image. In this way, when two plane mirrors are kept parallel to each other, infinite number of images can be seen.